Welcome to this channel. In this video, I'm going to be taking question 21 through 26 of IGCSE Cambridge October November series, paper 2 extended. The question 21 says the line y equals x plus 1 intersects the curve y equals x squared plus x negative 3 at 2 points. Find the coordinates of the 2 points. Right, so when there's an intersection, all you simply need to do is to equate the curves together, because this is y equals x plus 1 and y equals x squared plus x negative 3. So y equals x plus 1 and y equals x squared plus x negative 3. So since these two will have y, we could therefore say that if they're going to intersect, then y, which is x plus 1, is equal to y, which is also equal to x squared plus x negative 3. So you can see that there's an x here, there's an x here. So x and x cancels. So then left with 1 equals to x squared negative 3. And then we want to get the value of x. Question says find the coordinates of the 2 points. So you could add 3 to both sides, right? And that's going to be 3 plus 1, 4. 4 is equal to x squared, right? So x squared equals 4. So in order to solve this, you must be very careful, right? One way to do that is to simply move 4 to the left hand side of the equation. Then that's going to be x squared negative 4 equals 0. And then using the difference of 2 squared property, you know that a squared negative b squared is equal to a negative b into a plus b, right? A negative b into a plus b, right? So for x squared negative 4, we're going to have x squared negative 2 squared is equal to 0. So that's the same as x and negative 2 into x plus 2 equal to 0. That's in accordance with a squared negative b squared equals a negative b into a plus b. So then we equate each to 0. So x negative 2 is equal to 0, or x plus 2 is equal to 0. So then negative 2 crosses, or we add 2 to both sides. We have x equals 2, or then plus 2 moves over to become negative, and x equals negative 2. So x is equal to 2 or negative 2. So question says find the coordinates. So we're talking about coordinates, we're talking about x and y, right? So you could pick any of these equations, y equals x plus 1 or y equals x squared plus x negative 3, and substitute the value of x. So the simple one to take here is y equals x plus 1. So we've gotten that x is equal to 2 or negative 2. So when x is 2, 2 plus 1, that's going to be 3. And when x is negative 2, that's going to be negative 2 plus 1, and that's negative 1. And we find out that even though you should substitute 2 into this equation, you're also going to have the 3. If you substitute negative 2 here, you're also going to have negative 1. So using the coordinate system, the left hand side corresponds to the x coordinate, the y coordinate. So x is 2, y is 3. X is negative 2, the output negative 1. And those are the two coordinates where the line 9 y equals x plus 1 and y equals x squared plus x negative 3 intersect, right? Next question says x is inversely proportional to the square root of w. When w equals 16, x is 3. Find x in terms of w. So when you hear the term inversely proportional, that's like an inverse 1 over a number, right? A variable. So x is inversely proportional to the square root of w. It's the inverse. If the question said directly proportional, what we're going to have is x is directly proportional to the square root of w, but this is the inverse, right? Inversely proportional. And then when you have a proportional sign, in order to remove that sign, what you're going to do here is to change this to an equal sign and then add a constant, which is the constant of the proportion. So that becomes equal to k times 1 over root w. So we then, it's given to us in the question that w is 16 when x is 3. So we simply substitute. So that means you're going to have 3 equal to k over root w is 16. So k is equal to 3 times root 16 So root 16 is 4. 4 times 3 is 12. So that means the value of k is 12. So the question says find x in terms of w. So that implies that if you're given a question like this, all you need to do is to get the constant of proportionality and then come back here, and that's what they need. So since we have x is equal to k root w, and based on the information we're given, we got k to be 12, so we could then say that x is equal to 12, which is k over root w. So we've expressed x in terms of w. Okay, question 23 says, some students record their reaction times. The table shows the results, reaction time, frequency, 0 t, 0 less than t less than or equal to 6, 6 less than t less than or equal to 10, and then the frequencies were given. So he goes on to say that on a histogram, the height of the block for the 0 less than t less than or equal to 6 interval is 7.5. The question then says, calculate the height of the block for the 6 less than t less than or equal to 10 interval. So in order to get this question right, you have to understand that when you're plotting a histogram, what you're going to have here is the data. In this case, we're looking at the reaction time, and then what you're going to have on the y-axis is the frequency density. The frequency density, and it's important to know that the frequency density is equivalent to the frequency divided by the class width. The class width, right? So the frequency here is 18, right? While the reaction time, we're looking at the class width, it starts 0 less than t implies that t is greater than 0 and then less than or equal to 6. So from 1 to 6. So 1 to 6 we have 5 values, right? We have 6 values, sorry. So the class width is 6. So the frequency density is 18 divided by the class width, which is 6. Because from 1 to 6 we have 6 elements, right? And then that's 3. The frequency density is 3. Then let's look at 6 less than t less than or equal to 10. Then we have 16. So the frequency is 16. What's the class width? We could say t 6 less than t, which implies that t is greater than 6. So we have 7, 8, 9, 10. So that's going to be 4 values. So the class width is 4. So 16 divided by 4 is 4. So what's the essence of this? It's important to know that the height of the histogram is proportional to the frequency density, because it's actually what is going to determine the height. If maybe what you have here is 1, 2, 3 is the frequency density, that helps you know that, okay, this is where the height is going to be. But it's likely that the students use a specific scale to plot the histogram, right? Maybe it's a case of 2 cm representing, right? Stuff like that. So, but the frequency density will be proportional to that scale chosen. So how do we get that? So the frequency of the 0 less than t less than or equal to 6 class is 3. That's the frequency density. And then that of the 6 less than t less than or equal to 10, we had 4. And that's going to be proportional to the heights that are going to be there. Right, so the height of the 0 less than t less than or equal to 6, we had 7.5. I can see that it matches with this. So this was for 3, which was for the 0 less than t less than or equal to 6, and then we have that the height is 7.5. And then the 4, which corresponds to the 6 less than t less than or equal to 10, we don't know. It says what's the height of that. So because there's a proportion, we can then use that as an advantage, and then we could multiply through. That's going to be 3 times x is equal to 4 times 7.5. So 4 times 7.5 gave us 30. So 3x is equal to 30. Then dividing through by 3, we're going to have that x is equal to 10. So on the graph, we're going to have it as 10 cm, because the heights of the blocks are proportional to the frequency densities, right? Okay, question 24 says, simplify ax negative 2a negative x plus 16 divided by a squared negative 1. So we can simply collect the like terms here. And then what we're going to have is ax negative x, negative 2a plus 2, because there's a factor of 2 here. We have x here, we have x here. So we factor out x, and then x is common to ax and negative x. So ax divided by x is a, right? And then negative x divided by x is negative 1. And then negative 2 is common, so we could factor out negative 2. And then negative 2a divided by negative 2 is a. And positive 2 divided by negative 2 is negative 1. So we could then take this and this. Then we're going to have that x negative 2, a negative 1. And then remember, so that implies that we have x negative 2, a negative 1, all over a squared negative 1. Let me bring that closer. It's looking far apart from themselves. Okay. That's a negative 1. So using the property, remember when I talked about the difference of two squares, where I said that a squared negative b squared is equal to a negative b into a positive b. So a squared negative 1 squared is equal to a negative 1 into a plus 1. So that's going to be x negative 2 into a negative 1 all over a negative 1 into a plus 1. So this a negative 1 can cancel this, and then we're left with x negative 2 over a plus 1. And that's the simplification of the expression given to us in the question. Okay, question 25 says, the derivative of 2ax to the 7 plus 3x to the k is 42x6 plus 15x to the k negative 1. Find the value of a and the value of k. So it's important to know that if you have an expression in the form y equals ax to the n, the derivative, which is dy dx, is going to be equal to nax. That means that n comes down, right? N comes down, and then nax to the n negative 1. So let's do that. So we have 2ax to the 7. So what happens? 7 comes down. So that's going to be 2 times 7 times a times x to the what? 7 negative 1. Right? And then let's look at this part. 3x to the k. So what happens? K comes down, right? Because that's the power. K comes down. So we're going to have 3 times k times x to the what? K negative 1. Right? So 2 times 7, 14. So 14a, then 7 negative 1 is 6. So 14a6. Sorry. This is 2 times 7. That's 14. Then times a, then x to the 7 negative 1. 7 negative 1 is 6. So that's 14a x6 plus 3 times k, that's 3k x to the k negative 1 will be equal to what's given, which is 42x6 plus 15x to the k negative 1. So you can then see that we could compare 14ax6 with 42ax6 and 3k xk negative 1 with 15xk negative 1. So 14ax6 will be equal to 42x6. So this could cancel. Now we have that 14a is equal to 42. And then to get the value of a, we'll divide through by 14, and a is equal to 3, right? So we place that here. And then we compare 3kx to the k negative 1 with 15x to the k negative 1. So these two cancel, right? And then we have that 3k is equal to 15. And then dividing through by 3, we have that k is equal to 5. Right? So k is 5. Yeah. Last question says, diagram shows a parallelogram OPQT. The position vector of P is A and the position vector of T is B. K is on PQ, so that PQ is to KQ is 3 is to 1. The lines OK and TQ are extended to meet at X. Give the position vector of X in terms of A and B. Give your answer in the simplest form. So in order to do this, the question is the position vector of X. The position vector of X is simply equivalent to OX, right? That is this length. This, right? So how do we achieve this? So we have to follow the direction number 1, and then one stuff the question is giving us here is that PK to KQ is 3/1. So if that is true, remember when we do it, you should have done ratio division, maybe dividing the quantity in a ratio. So we have PK to KQ. So 3 plus 1 is 3, right? 3 plus 1 is 4. And then we have PQ. This is PQ. And then this is a parallelogram. So if this is 0, 2 and it's parallel, we have B here. That means this side PQ is also having a B. So that's going to be 3/4B. So PK is 3/4B. K is 1/4B because that's taking this proportion, right? So the question now is OX. So in order to get OX, all we simply need to get here is say OT plus TX. That's the simplest way. So OX is equal to OT plus TX. Now pay close attention. This is OX. We're trying to achieve this vector. So to achieve this magnitude, what do? We move this way, right? OT TX is gonna cover this entire OX, right? So that's OT plus TX. So TX is also equal to TQ plus QX, right? So we could then rewrite that as OX is equal to OT plus TQ plus QX. So now, what's the value of OT? OT is equivalent to B. It has B as position vector. So that's B, clear. Plus, what's TQ? Now this is a parallelogram, so if here is A, here is also A, right? So that's B plus A plus QX. So the question now is, what is QX? Let me clean this off so that we see clearer. QX. So you then have to employ the theory of similar shapes. So you can see that the triangle K, that's KQX, is similar to the triangle OKP, right? Because you could say this is parallel line and then this is also parallel, right? Because it acts along the A line, right? So we can then compare QX to OP, that's QX to OP, and then QK with KP, right? So QX, so using the ratios of similar shapes, we have that QX divided by, that's QX to this length, QX to OP, which is A, right, is equal to what? The ratio, which is QK KP. And in this case, you're given that PK to KQ is 3:1, which implies that KQ to PK is 1:3. KQ, which is this, and PK, which is this, is 1:3. So it's still same. So you say that QX over A is equal to 1/3. So if we multiply through by A, we have that QX is equal to A over 3. So OX is equal to B plus A plus A over 3, and then that's B plus A can be written as 3a over 3 plus a over 3, and that's b plus 4a over 3, and that's the position vector of x, right, in terms of a and b. Thank you so much for watching this video. We have successfully completed paper 2 extended October November 2023. Thank you so much for watching. Remember to like this video, share this video, right? You also subscribe if this has really taught you big time. Thanks once again, and have a nice day.